Welcome to Fuzzy Mathematics, the basics. In the previous lecture, we have talked about Hasse diagrams, which are used to represent posets, partial ordered sets. Elements of partial ordered sets that have certain extremal properties are very important. In this lecture, we are going to talk about maximal element, minimal element, greatest element, least element, upper bound, lower bound, supremum, and infimum. First, let's introduce the definitions of maximal element and minimal element. An element in a poset is called maximal if it is not less than any element of the poset. That is, an element U is called the maximal element of the poset if there is no element X such that U is less than X. Similarly, an element in a poset is called minimal if it is not greater than any element of the poset. That is, an element L is called the minimal element of the poset if there is no element X such that X is less than L. The maximal element is not less than any element of the poset. The minimal element is not greater than any element of the poset. Next, the definitions of greatest element and least element. An element in a poset is called the greatest element if it is greater than any other elements in the poset. That is, an element U is called the greatest element of the poset if X is less than or equal to U for all elements in the universal set. The greatest element is unique when it exists. Likewise, an element in a poset is called the least element if it is less than any other elements in the poset. An element L is called the least element of the poset if L is less than or equal to X for all elements X in the universal set. The least element is unique when it exists. The greatest element is greater than any other elements, and the least element is less than any other elements. Next, the definitions of upper bound and lower bound. Let A be a subset of a poset. Sometimes it is possible to find an element that is greater than or equal to all the elements in set A. An element U is called an upper bound of A if X is less than or equal to U for all elements X in A. Similarly, there may be an element less than or equal to all the elements X in A. An element L is called a lower bound of A if L is less than or equal to X for all elements X in A. An upper bound of set A is greater than or equal to all elements in A. A lower bound of set A is less than or equal to all elements in A. Next, definitions of supremum and infimum. Let A be a subset of a poset. Element alpha is called the least upper bound of A if alpha is an upper bound of A that is less than any other upper bound of A. An element alpha is the least upper bound of A if alpha is an upper bound of A and alpha is less than or equal to U whenever U is upper bound of A. The least upper bound is also called supremum. The least upper bound or supremum is unique when it exists. We write as follows: alpha is the supremum of A. Similarly, if beta is a lower bound of A that is greater than any other lower bound of A, then beta is called the greatest lower bound. An element beta is the greatest lower bound of A if beta is a lower bound of A, and L is less than or equal to beta, whenever L is a lower bound of A. The greatest lower bound is also called infimum. The greatest lower bound or infimum is unique when it exists. We write as follows. Beta is the infimum of A. We use some terminologies to denote the least upper bound of A, or the supremum of A. We also use some terminologies to denote the greatest lower bound of A, or the infimum of A. Now let's do some examples. First, example 1. Suppose A is the set with 5 elements, 1, 2, 3, 4, and 6. Set A together with the divisibility relation is a poset that is represented by the following Hesse diagram. Firstly, which elements of this poset are maximal and which are minimal? The maximal element is not less than any element of the poset. 4 is not less than any element of the poset, and 6 is not less than any element of the poset. 4 is the maximal element, and 6 is the maximal element too. The minimal element is not greater than any element of the poset. 1 is not greater than any element of the poset, so 1 is the minimal element. Maximal and minimal elements are easy to spot using a Hesse diagram. They are the top and bottom elements in the diagram. Next, determine whether the poset has a greatest element and a least element. The greatest element is greater than any other elements in the poset. This poset has no greatest element. The least element is less than any other elements in the poset, so the least element is 1. The least element is unique when it exists. Next, find upper bounds and lower bounds of the subsets 1, 2, 2, 3, and 4, 6, if they exist in the poset. An upper bound is greater than or equal to all the elements in this subset. A lower bound is less than or equal to all the elements in this subset. So, the upper bound of set 1, 2 is 2, 4, and 6, and its only lower bound is 1. The upper bound of set 2, 3 is 6, and its only lower bound is 1. There is no upper bound of set 4, 6, and its lower bound is 2 and 1. Next, find the supremum and infimum of subsets 1, 2, 2, 3, and 4, 6, if they exist in the poset. The supremum is the least upper bound. The infimum is the greatest lower bound. The supremum of set 1, 2 is 2, and its infimum is 1. The supremum of set 2, 3 is 6, and its infimum is 1. There is no supremum of set 4, 6. Actually, there is no upper bound of set 4, 6. The infimum of set 4, 6 is 2. As this example shows, that a poset can have more than one maximal element or more than one minimal element, but the greatest element is unique when it exists, and the least element is unique when it exists. It is also easy to determine whether two elements are comparable using Hesse diagram. For instance, 2 and 4 are comparable, but 2 and 3 are not comparable. Another example, example 2. Suppose X is the set with the 3 elements A, B, and C. The poset of X together with the inclusion relation is a poset which is represented by the following diagram. The empty set, singleton A. A set with one element is called a singleton. Singleton B, singleton C, set AB, set AC, set BC, and set ABC. Firstly, determine whether this poset have a greatest element and a least element. Using this Hesse diagram, it is easy to see that the greatest element of this poset is the set ABC, the universal set, and the least element of the poset is the empty set. Next, determine whether every two elements are comparable in the poset. The subsets A and AC are comparable because A is a subset of AC, and there exist two elements in the power set that are incomparable. Set A is not a subset of set B, and B is not a subset of A. Set A and set B are incomparable. In this lecture, we have talked about elements of posets that have certain extremal properties. Next time, we are going to talk about a special type of posets, lattices. Thank you.